let's say you need to access length method from string, but for example you need to do it in many places, or you need to do operations, many operations on this string. So every time you execute an operation, you need to use casting. So there is one reason to solve this problem. You can use smart casting to not cast this nullable string type as normal string to access these methods and functions, but you can write it like here. First, you use if else, so we check if our string is null, and if it's not, we want to access value methods or functions. And as you can see, this is smart casting. So now compiler treated this as their variable as non-null, because I previously tell him that it can't be null because I check it with if. And now I can do the other operations as well, like them. And now we have something like this. And now let's say we want to add some abstraction. So let's say our code is expanding and there are more and more things to check and to do. So now we create a function like fun is string. We return, of course, boolean, because we want to check if our string is null. So we want to pass a nullable string and check and return str not null value, of course. Yeah, and now we do it in here and use is string on our str. And now it doesn't work. It doesn't work because now compiler treated str as nullable type. So why and how to avoid it? So in the previous example, compiler treated str as non-nullable because we checked it previously. But now with isString str, compilers doesn't know what isString will return. So we need to tell him some facts about this function, and that's why we use contracts. So we can use function like this. I will explain it later. And we can it's not this is function, yeah. And now we can use this function, and we tell compiler that if this string returns, so if x is string, if this function returns true, it should implies that x is string. And now I run it. I run it and it works, but I don't use any print line, so nothing is shown on the screen. But yeah, but without it, compiler doesn't know anything about this str. It's treated like it was nullable because it's the last information he had about this variable. But with contract, we tell explicitly compiler that if this function returns true, it should treat it as string. So we inject in Kotlin this thing, we can call it. And now we can use isString in many places. We can expand this function as we want, but of course you need to remember to use opt-in, because it's an experimental function, so without it it won't work. So what are the other examples of using smart casts and contracts? I prepared some examples, and it's one of them. So let's say I have a value with type any, which is string, but it can be anything like the type declares. And now I can check with when value and smart casting, and I can cast in a runtime this thing to other types. So I use value is string, and now I have an access to all string methods and functions, because compilers know that this value will be a string. And in this example, compiler treated as int. And the last example with smart casts is this. So when we treat str as an nullable type, and now without it, compiler of course treat it as a nullable, so we need to use Elvis operator to access this length method. But with this casting, compilers note that after we check the string is not null, it will treat it as a non-nullable. And new example with user. So we create a data class user with a variable name, and we create a contract. We create a contract, but something is off. Yeah, because I use it in here, so I need to comment it. And yeah, everything is working now. And with this contract, we can use to implies that if user won't be a null, it should apply is not null. So for example, I create a user with a name like, for example, Michael, and I tell compiler that user is a nullable, and then I use require user, I pass user, which is nullable, and then I can access name property, because compiler knew that it will be not null, but without it, it is nullable type. With this, compiler have a contract that if user returns true, so if user won't be a null, so returns will be correct, it should implies that user is not null. So it's worth to use smart casting, to not use, as I previously mentioned, as, and as in many places, and the contracts to use functions, and not smart casting in everywhere. But it's worth to mention the last thing, that smart casting is working only within the context of the variable, within the context of check. So in here, compiler treat it as non-null, but beyond this function, it's still a null, because only within this context of this if else operators, it's a non-nullable thing. So I hope it was a helpful video for you, and I hope you like it. So if it, subscribe and like it, and thank you for watching.